since last year, we've managed to prepare a book on ISTQB AI testing syllabus. It is based on a software testing course that we have, and we already help a number of students to prepare to learn more about AI technologies. And I would like to quickly talk about some ideas and why we think this book is important. So in any area, including software testing, definitions are important. So two terms, AI and testing. So testing is easily identified. So testing is exploring software with intent of finding bugs. And the main output of the software tested work is defects detected and described. So our main output is how we find defects and how we describe them. One of the best materials for, well, it's initially for junior testers, but I believe it is also a very good reminder for anyone working in software testing, is that defects is our main output, and the quality of our work is essentially the quality of information that we provide. There is a very old article about it, a white paper that stands for Can Pick Right, and it describes all the main features of a good defect report. And if you look at this list, you will also notice that they, to a degree, represents ability to think and intelligence of the software tester. In particular, things like ability to generalize or isolate the problem is something that separates a very intelligent software tester from an ordinary software tester. And these interesting terms, isolate and generalize, also become relevant when we talk about AI. So what is AI? And here people are not able to agree on generalized enough or localized enough, isolated enough definitions. Some people believe that anything that involves machine learning is AI. Others think that only large-scale foundation models are AI. So it is a spectrum. And when somebody is speaking about AI, it is usually helps when they're trying to either generalize the statement or isolate the statement for the sentence to make sense. The perception of AI and what is AI. So here's one thing. The most general definition of AI is that AI is software. And this definition might initially seem as too generic to be practical. But in fact, it is very practical in your day-to-day work. This way. So most of you will either write something about AI or read something about AI in the very near future. And here's a simple rule how to check that the text makes sense. If you take the text that contains words AI and replace AI with software, you can see if the sentence still makes sense. If not, then probably you need to try to formulate it a bit differently. Example given by Michael Bolton is a McKinsey study claims that software developers can complete coding tasks up twice as fast with software. So it's more or less okay. So it's still possible to use AI and software here. My other example that I like is this one. AI is not the enemy, it's your personal growth partner. So we will look at this sentence and we will try to replace word AI with software. And then it sounds like software isn't your enemy, it's your personal growth partner. And this sentence, it has the same meaning or sense as stairs isn't the enemy, it's your personal growth partner. So in any material, so say you design a test plan for AI systems, or you write AI strategy for your company, or you do something like that. So just simple exercise, go and replace AI everywhere with the word software. And maybe it is not that you need to remove the word AI. You can certainly keep it in your work. But the idea is that when you do this check, the text becomes better. So immediately I remembered that we do have AI in the title of the book. So I read to check what will happen with the title of the book if we will replace AI with software. And the title of the book now is Introduction to Software Testing. And I have no problems with that. Because in reality, ISTQB AI testing syllabus is very relevant to testing any type of complex distributed software. Many things that are absent in CTFL are present in AI testing syllabus, and that's why it is good. In particular, it contains lots of information about test oracles that is completely absent in foundation level. And of course, it is present in our book. So this is also another example of a text where replacing AI with software doesn't make sense. But if you are set on this Friday, and if you want to have some, I would say, guilty fun listening about software testing, there is a special event carried out by Joe Colantonio from Test Guild about software testing. It will be run in the form of debate. So most of the panels that you see on software testing will be something like that. Test automation is not a solution for all problems, the first speaker says. The second speaker says, I agree with the first speaker that test automation is not a solution. And the third agrees with the previous two. In this case, we will have two completely different positions on a number of topics. So if indeed you want to have some fun, please do register at Test Guild. I hope it will be worthy of your time. Now back to definitions. So what is software? So software on one hand is a set of instructions, and on another hand, it is also a set of data. So instructions are, in essence, are stored in a form of data. And it is also helpful to explore it because data exist in several forms and software exists in several forms. So all AI is software. Not all software is, of course, AI. So we have very detailed review of many AI technologies. So we are trying to isolate individual technologies. We also review things like AI effect, something that was considered an AI a few years ago is no longer an AI, is no longer isolated definition of AI. So we do have lots of materials in the book. But back to data. So software is data, and data has two types. The first type is handcrafted. It is created by humans. So something that a human can create. And synthetic. It is something created by software. So in order to create data, a human needs to interact with it. Why it is jumping? Okay, it's not that. Okay. Now, yes. So data created by humans is natural. Data created by software is artificial. To create data, humans need to interact with it. So data handcrafted by natural humans is interactive because humans interact with it. They apply their ideas and they create data. And software generates data. To interact with software, humans need to be in attendance of the data to participate in interaction. So correct term is attended data. And the opposite of attended data is, of course, unattended data. And then finally, the favorite word is the synonym for handcrafted is manual, and the synonym for unattended is automated. So this is true for the data. So it is possible to have data that is attended, so somebody is working with data. And it is also possible to have data that is unattended. And probably all of you can see some similarities with other terms that are used in our craft. In particular, there are many discussions of what is exploratory testing, and exploratory testing and use tools. Exploratory testing most of the time is attended. Why I jumped in? Exploratory testing is attended. So a human is present near the software and interacts with it, but still they can use another software. So there is probably no strict scripted testing or exploratory testing. It is continuum from scripted to exploratory. And what is fun, the term itself, exploratory testing, appeared when Kem Kanner was thinking about exploratory data analysis. So he was thinking about exploratory data analysis and thought that maybe something like that would also be applicable to software testing. And now, when every application consists of tons of data, the only way to really do software testing is, of course, to analyze data. So exploratory data analysis is back, so we have a full circle. Exploratory testing appeared from exploratory data analysis, and now modern exploratory testing is, of course, in fact, exploratory data analysis. In our book, we have a number of practical tasks and workshops specifically designed to explore exploratory data analysis. Finally, Finally, apart from having two different types of data, handcrafted and synthetic, there are also two different volumes of data. So the first volume of data, type of volumes, is artifacts or snippets. This is a volume of data that a human can process interactively. So if a human can process particular amount of data, this data is called an artifact, and it is also can be processed by humans. Substantially larger data sets can be called data sets or corpuses, and their main feature is that they can't be processed by a human just due to their size. So humans can only interact with artifacts. Software can interact with both artifacts and dataset. If a human can interact with the dataset, sorry, it's no longer a dataset, it's an artifact due to its size. On the other hand, humans can create natural artifacts, and software can create or process both artifacts, can create synthetic artifacts, and can also read any data or produce any data. So in the forms of data sets or corpuses. And what it means that there is, to understand the relation between what humans can do and what software can be used for, it is necessary to look at it in terms of software, data, data sets, and artifacts. So we know that humans have intelligence. We do not know what intelligence is. We know that humans store knowledge in forms of ideas, and they convert ideas into natural artifacts and back. And they also can process various artifacts, not data sets. Software has no ideas, but it is able to process data sets and artifacts. The only way we can judge human intelligence is the artifacts that they produce or actions that they perform. And the same is for synthetic intelligence, for artificial intelligence. So the only way to evaluate it is to look at a proxy, at ability to process various artifacts, but not even data sets, because we are not able to understand what happens with the data sets, because it is some alien intelligence for us. Because we, as human, we only have cognitive ability to process artifacts. Finally, to build software testing for a complex system, whether it is AI-based or not AI-based, if we have a very complex system, we will have to build a very elaborate test harness and a set of test scenarios. The cool idea here is that even if your current test tools or test scenarios do not use any technology, any AI technologies, but they are large enough, they have exactly the same problems that any type of AI software. So in order to understand a huge test library, one has to deal with the questions of transparency, explainability, interpretability, autonomy, and everything else. That's why what we have in AI testing syllabus is also applicable to any type of software that is just sufficiently complex. And that is it. The best part of the book is, of course, its design and its main characters. And if you're still here later today, please do attend a session by two of my colleagues that will talk in more depth about metamorphic testing and digital twins. Thank you very much.